Hi, in this video we will discover and then use the exponent rule for dividing two quantities that have the same base. To illustrate, x to the fifth, if you go back to the meaning of what an exponent is, means this. And then x squared means this. If you remember right, when you cancel, you can cancel identical factors on top and bottom. So I really say x goes into itself once, x goes into itself once, x goes into itself once, x goes into itself once. And as you can see, I've run out of x's in the bottom of the fraction. The top of this fraction now looks like 1 times 1 times x times x times x, which is just x to the third. And on the bottom, you go 1 times 1, and that's just over 1. And that's really the same thing as x to the third, because writing it over 1 is optional. Notice the number of x's that I had in the top was more than the amount I had in the bottom. So when I canceled 1 for 1, it's clear that I ran out of the x's in the bottom of the fraction first. Notice the number of x's that remained in the top was how many more x's there were in the top to begin with. Let's come down to the second problem. Notice the size of the exponents. There's no way I want to write out 500 x's all in a row, or 475 x's all in a row for the bottom. Clearly that's not efficient, but we can envision what that would look like, and we could picture ourselves canceling 1 for 1. Because there are fewer x's in the denominator, we can see that we would run out of x's there first. And we're now asking ourselves how many x's would remain in the top. We could see how many more x's there were in the top to begin with. So what we're going to do is we're going to subtract 475 from 500, and that tells us that there would be 25 x's that would be remaining in the top. So all of them would go away in the bottom. That would just be a bunch of ones all multiplied together. And in the top you'd have x to the 25th. Since we canceled 475 x's from both the top and the bottom, to see how many remain in the top, we did a subtraction. This kind of leads to the rule that says if the bases are alike, you may subtract their exponents. So you should write subtract in the blank to finish off the rule. Well, let's look at these additional problems together. Notice in the top problem, it's the first time we've encountered a larger exponent in the denominator than in the numerator. The ideas do not change. Picture 2 factors of x on the top and 6 factors of x on the bottom, and us canceling them 1 for 1. Because all the x's will cancel out of the top, it'll just be a 1 times 1 remaining up there. On the bottom, I'll have 4 remaining factors of x, which I can write most efficiently this way. For those of you who said, wait, I thought you said we could just subtract the exponents. If you had gone x squared and then minus the 6 on the bottom, you would have gotten x to the negative 4. Something that we haven't really formally discussed yet is that maybe these are 2 ways of looking at the same thing. We'll discuss that in a later video, but for now I don't really mind which way you write it. Let's look at the next problem. That's really 3 factors of x over 4 factors of y. Well, I don't know if you realize, but you can't cancel an x with a y. So nothing reduces, and what you're left with is 3 factors of x, most efficiently written this way, over 4 factors of y, most efficiently written this way. And it turns out that the way the problem was originally written ends up being the most simple way to express it. Looking at the final example, notice there are a's in the top and w's in the top. Same thing with the bottom. Well, if I were to expand them all, you can cancel A's with A's and W's with W's. So you can really treat these separately. So basically what you're going to do is you'll have 5 factors of A on the top, 7 factors of A on the bottom. That means you're going to have 2 remaining factors of A. And then you have W to the 3rd on the top and W to the 9th on the bottom. So that means there are 6 additional factors of W in the bottom. And what you have left on the top is not a 0 again, but it's the 1 times the 1 that you would have gotten when you reduced. So it ends up being 1 over A squared W to the 6. And that would be your final answer. We have one very important distinction to make before I can set you on your way. I think we'll first look at these numerical examples in the second half of this screen. Basically, you see the 3 times a 6. If I were to do this out the long way, I would end up with 18 over 3 times 3, which is 9, which we know comes out to the number 2. Notice, if I choose to do this with canceling, I can cancel the 3 with the 3, and I am left with 6 over 3, which gives me the same value of 2. What this verifies is the kind of canceling I just did was legal to do, because it didn't change the value of the quantity I started with. Let's look at this second example. If I do it out the long way, I'm going to get 3 plus 11, or 14, over 3 plus 4, which is 7, and that's equivalent to 2. If I use my shortcut, or my supposed shortcut, of canceling these 3's, I end up with 11 fourths, which I know is not equal to the number 2. So what I've just shown is this type of canceling right here is illegal to do. And what makes this kind illegal to do is because of this plus sign right here. When you have a sum, you may not cancel one of the 2 things being added. You can't cancel one of the addends. What it ends up doing is it ends up changing the value of your fraction. And since we're just merely trying to simplify, we're not supposed to be changing the weight of it, just how simply it can be written. Over here, this was a product. And I can cancel a factor of 3 with a factor of 3 because it ends up producing a fraction that's equivalent in value. So all through math, we sometimes pick up bad habits and make our own rules without even realizing it. Just know canceling in a fraction can only happen if the top and the bottom are both expressed as multiplication and if what you're canceling are identical factors. Let's apply this idea to the fraction that you see at the top of the screen. The a to the 5th plus w to the 3rd is written as a sum, and so is the bottom. The fact that it's written as a sum means no canceling can happen. So I'm not allowed to take the a to the 5th and the a to the 7th and rewrite it more simply. I'm not allowed to work with the w's in the same manner, because to cancel would change the fraction, and it would no longer be equivalent to the original fraction that I started with. Here are 4 problems for you to try on your own. So pause the video and then bring your answers to class. I hope this video was helpful.